Hello students, let us discuss the structure of interhalogen compounds. As we have discussed, the four type of interhalogen compound, that is XS dash, X, X dash 3, X, X dash 5, X, X dash 7. Here instead of writing X dash, Y is written. Both X and Y are the halogens. So these are the four type of interhalogen compound. So when we look at the shape of these, that is X, Y, that is CLF example is linear shape, CLF3 T-shaped, Brf5 square pyramidal, and IF7 have pentagonal bipyramidal shape. So this is the three-dimensional shape of these molecules which is shown here. Now how to learn the structure very easily, that we need to discuss here. So first of all, last year we discussed about the different geometries depending upon the valence shell electron pair repulsion theory and the hybridization. So first of all, you need to learn this table. So in this, the trigonal linear geometry, trigonal planar, tetrahedral, trigonal bipyramid, this is octahedral, this is pentagonal bipyramid. So here these numbers you need to remember so that we can come with this structures, and the hybridization also you need to learn in this order. So first of all, CLF because their structure is linear, so no need to discuss much more about this one. Next one is Brf3. Structure Brf3. For this, better you make the Lewis structure. As we know that the central atom is Br here, write it in the center, central atom Br, and the 3 terminal atom, that is 3 fluorine, you need to write in the terminal like this, each having 7 electron in its valence shell because both are halogens. So make the 7 dots as shown here. From the 7 electrons, that is the 7 valence electron of Br, it share 3 electron with 3 fluorine in this way. Now you can see here, now surrounding to the bromine, there are 3 bonds, that is the 3 bond with 3 fluorine. So when you find out the number of bond pair and lone pair, as we done last year, here bond pair is representing the number of bonds surrounding to Br. We are finding for Br, that is the central atom, 1, 2, 3. There are 3 bonds, and when you check the lone pair toward around the bromine, there are 2 lone pairs also there. That is the non-bonding electron pairs. So Bp is representing the bond pair, Lp is representing the lone pair. So to the central atom Br, the number of Bp and Lp, that is 3 plus 2. 3 is the bond pair, 2 is the lone pair, that is sum is equal to 5. Now you are getting the number 5. So just go into the chart 5. 5 means what is the geometry? That is trigonal bipyramidal. So you have to learn in this way. Once you have learned the chart, you can easily come up with the structure. So what is the geometry? Trigonal bipyramid, because we got the total number of bond pair and electron pair, bond pair and lone pair, that we are getting 5. So the geometry is trigonal bipyramid and the hybridization is sp3d. So you will be making trigonal bipyramid structure for Bf3 because we got the total number of electron pair, that is 5 here. So we'll be making the trigonal bipyramidal geometry in this way. Now here, because there are 3 fluorine atoms, that is the 3 terminal atom, and there are 2 lone pairs. So out of the 5 terminal position here, these are the 5 terminal position, 3 position will be occupied by the fluorine and 2 positions are occupied by the lone pair. So where we have to keep the lone pair and where we have to keep the fluorine, these 3 positions that is called as the equatorial position, and these two positions are called as axial position. Equatorial position, that is the angle it having 120-degree angle, and the axial position is actually having 90-degree angle with the plane. So last year we have learned that lone pair repulsion is a maximum, then lone pair, then bond pair. So always the lone pair will try to occupy the maximum angle. So the lone pair will occupy which position? That is the equatorial position. So we'll be keeping the two dots in this way, or otherwise we can keep the lone pair in this way. So the two lone pair is occupying which position? That is the equatorial position in the trigonal bipyramidal geometry. Now it is after keeping the lone pair, now we have to keep fluorine. So the 3 terminal position which is vacant here, so we'll be keeping 3 fluorine like this. Now this is the structure for, that is a trigonal bipyramidal geometry for Brf3. So whatever x-3 examples are there for a interhalogen compound, the geometry will be in this way. So as I told you, this is the geometry for Brf3, that is trigonal bipyramidal. But what is about the shape? When we are taking the shape, at the time we need not to consider the lone pair. So when we not consider the lone pair, then at the time what will be the shape? Shape will be like T shape. You can see now it is like a T shape. So the geometry is trigonal bipyramidal, but the shape is T shape. Now you can see this is T shape with 2 lone pair which is shown here, and this is T shape. So the shape for this molecule is T shape and the geometry is trigonal bipyramidal. Next one, Brf5, that is the type of interhalogen compound XX-5. Here also we'll be doing in the same manner. First of all, we need to make the Lewis structure. Br is the central atom, so we'll be keeping the Br in the center, and the number of fluorine here, there are 5 number of fluorine, so you need to make the 5 fluorine in the terminal position, and here each having 7 electron in its valence shell, so that you are making 7 electrons in the valence shell. From the 7 electron Br, that is having a 7 electron, 1 electron is shared with 1 fluorine. Like this, it will share the, out of 7, 5 electron it share with the 5 fluorine. So how much is remaining? It is 1 lone pair is remaining here. So out of 7 electron for bromine, 5 electron it share with the 5 fluorine atoms. So remaining 2, the 2 will remain with Br as a lone pair. So what we can say that from this it is clear that there are 1, 2, 3, 4, 5 bond pair, and there is 1 lone pair with the Br you can see in the as a dot, 2 dots, that is a lone pair. So there is 1 lone pair. It's a pair. It's not number of electron. It is a pair. So there are 5 bond pair and 1 lone pair, that is equal to 6. So when you are getting the total electron pair is equal to 6. So the geometry, that is actually, look at this chart. What is the geometry when we are getting 6? That is octahedral. So we need to make octahedral geometry and sp3 d2 hybridization for it. So make the octahedral geometry as we have made here octahedral geometry. Again here, where we need to keep the lone pair, because there is 1 lone pair here, where we need to keep. These positions, that is the axial positions are there, and these are the 4 terminal position of the square. So where we need to keep the lone pair, because here all the angles are 90-degree angles, but if we are keeping the lone pair on the axial position, then it will be the more satisfied region where it will have a minimum repulsion. So this position is the correct position in the case of octahedral geometry. But in the case of trigonal bipyramid, the equatorial position is the suitable position. So this position you have to give for the lone pair, that is one of the axial position, that is below the plane or above the plane. So we are keeping here the lone pair, and 5 fluorine atoms are there that will occupy the 5 positions in this geometry. So the geometry is octahedral. But what about the shape? When we are considering the shape at the time, we are not considering the lone pair. So if we not consider the lone pair, now how it will be the shape? The shape will be, because it is a square. You can see it's a square, and above the plane there is one fluorine. So we can say that it looked like a square pyramid. It's looked like a square pyramid. So that shape was explained here in the 3-dimensional structure which is given here. It's a 3-dimensional structure. In it's clear that it is a square pyramidal shape. Now IF7, we have already made the structure for IF7 last year. Here the central atom is I, and because 7 electrons are there with the halogen in the valence shell, all these electrons will be shared with the 7 fluorine. You can see 7 electrons shared with 7 fluorine, which are the terminal atoms. So it makes 7 bond pair. Count the number of bonds surrounding to the iodine, that is 7. And because here there is no lone pair with iodine, you can see there is no lone pair with iodine. So the number of bond pair is 7, lone pair is 0. So total number of pair is equal to 7. Now when you look at the chart, number 7 means the geometry is pentagonal bipyramidal. Hybridization is sp3d3. So we'll be making the structure, that is pentagonal bipyramidal. It's a pentagonal bipyramid. So that is a pentagon. You can see the 5 fluorine atoms are arranged in a pentagon, and one fluorine is above the plane, the other one is below the plane. So the 3-dimensional structure of these is shown here in this picture. But for in the exam, no need to make 3-dimensional structure. You can make this structure. No need to make this structure. Next, let us discuss the hybridization in these molecules. First, the type XX-3. Let us take one example, Brf3. The central atom is Br here. So the valence shell electron, that is 7 electron. It is 2 electron in the S and 5 electron in the P, that is Ns2 Np5. The general electronic configuration is Ns2 Np5. So in the ground state, 2 electron is in the S and 5 electron in the P. So in the first excited state, one of the electron from P get excited to the vacant d orbital. So now in the first excited state, you can see now there are 3 unpaired electron due to the excitation of one of the electron into D. So there are 3 unpaired electrons which is present here. So because 3 fluorine atoms are there, so 3 unpaired electron is needed to share. So now in the first excited state, 3 unpaired electrons are available. So these orbitals undergoes hybridization, that is intermixing, that is 1 s orbital, 3 p orbital and 1 d orbital undergoes mixing, that is 1 s, 3 p and 1 d. So the hybridization is sp3d. So the hybridization is sp3, and the geometry for sp3d hybridization, as we have learned already the chart, the sp3d hybridization, that is trigonal bipyramidal. So this we have already discussed with number 5. Geometry is trigonal bipyramidal and the hybridization is sp3d. So that is the hybridization of the molecule, that is XX-3 type of interhalogen compound, sp3d hybridization. For X dash 5 type of molecule, example Brf5, X dash 5 type of molecule is this one. Here also central atom, because both the atoms are here halogens, so central atom is the Br here. So we'll be writing the ground state electronic configuration, that is Ns2 Np5. From this, because 5 fluorine atoms are the terminal atoms, so 5 unpaired electron is needed. So in the first excited state, that is due to the excitation of one of the electron to the vacant d orbital, now we can see there are 3 unpaired electrons are available. 3 single electrons are available. But how many fluorines are there? 5 fluorines are there. So one more paired has to get excited. So that means in the second excitation state, now you can see there are 5 single electron, that is unpaired electron is available. So these undergoes intermixing, that is 1 s orbit, 3 p orbit and 2 d orbit undergoes intermixing, that is called as a result in the hybrid orbital, that is called as sp3d2 hybrid orbitals. So the hybridization is sp3d2. From this hybridization, you can see in the hybrid orbitals there are 5 single electron and there is 1 paired electron. So this one will be remain in the geometry as a lone pair. So as we have discussed in the case of Brf5, there are 5 bond pair and 1 lone pair. So that 1 lone pair is this one here. So the geometry according to the table which we have learnt here, that is for sp3d2, the geometry is octahedral. So we'll be making the octahedral geometry. From this, 1 is the lone pair, so we have to keep 1 lone pair and other 5 are bond pairs. So that is the structure for Brf5, geometry is octahedral and the hybridization is sp3d2. Next IF7, this also we have done last year. Here the central atom is I and the ground state electronic configuration Ns2 Np5. Here 7 electrons are there. 7 terminal atoms are there, that is 7 fluorine. So 7 unpaired electrons are needed. So 1p orbital, these paired electron get excited to vacant d. So like this all get excited. So we can say that in the third excitation state, there will be 7 unpaired electron. These 7 unpaired electron get hybridized. Now check what is the hybridization. This is the s orbital, 3 p orbitals and 3 d orbitals. So the hybridization is sp3d2. So these unpaired electron will share, that is these hybrid orbital will share with the 7 terminal atoms. The p orbital of 7 terminal atom share with the sp3d3 hybrid orbitals of I. So that is a geometry, and this we can already discussed in the case of this chart. So we are getting sp3d3, so the geometry is pentagonal bipyramidal. So when you learn this chart, it is easy to make the geometry shape and even you can predict the hybridization on the basis of this usually. So make the use of this chart for making the hybridization and structure. So this is the hybridization for Brf3, that is sp3d, for Brf5 sp3d2, for IF7 sp3d3. So this is all we have discussed here, that is the structure and hybridization of interhalogen compounds. So this is all about this video. Have a nice day.